All right, welcome to Unit 1-1. Algebra Basics is Unit 1. We're going to start with the real number system, and we're going to do it quickly because we kind of covered it in the review, but I just want to make sure your head is in the right place. All right, real numbers, right? The reason we have to have real numbers is because there are imaginary numbers, which you will be introduced to in Algebra 2. Real numbers are all numbers. Right? But under the category of real numbers, there's two other categories. Irrational numbers, which are decimals that never end and have no repeating pattern. Think mumbo-jumbo numbers, right? So things like pi are irrational, and the letter we use for irrational is I, right? Things that have non-repeating, never-ending, right? So things like the square root of 2 is irrational. Any negative square root, because that's going to make it complicated, right? These are all irrational. On the other hand, we have the rational numbers. All fractions and decimals that end or have a repeated pattern. Everything else, number-related, falls under rational numbers, right? And for rational, we use Q. Obviously, we can't use R, right? And these are the things, this is everything, right? So like regular numbers, whole numbers, fractions, decimals, everything, right? Everything are rational numbers. It's only when you start digging deeper into it that you get to the next level, right? Integers are the ones that you would most likely see on a number line, right? So you take out the fractions and you take out the decimals, and then you end up with integers. And for integers, we're going to use Z, right? And these are the number line numbers, right? So -2, -1, 0, 1, 2, 3, to infinity, right? In both directions. These are your integers, okay? And then below the integers, you're going to have two more categories. You're going to have whole numbers, and that's our W. And that, to be considered a whole number, you can't be negative. It's not whole if it's negative, right? So it's 0, 1, 2, 3, 4, 5 to infinity, right? And then natural numbers, your N is everything but the 0, right? So now it's 1, 2, 3, 4, 5, etc. into infinity. Right? So if you think about it, they're all part of rational numbers, but it's like you're getting further and further into categories that specialize, right? So all cars are cars, but then you have the make, Chevy, Ford, whatnot, and then within Chevy and Ford you have a model. You have the Escort, you have the Challenger, you have the Charger, right? So the further down you go, the more specific it gets. All the way down to natural numbers, which are also known as your counting numbers. 1, 2, 3, 4, 5. They're the ones you learn to count with, right? For whole numbers, we add the 0. For integers, what did we use? Z. You add the negatives, right? And then for rational, we used Q, I think. Yes. And for rational, we include the fractions, the decimals, and all the other numbers, right? So -1, 0, 1, everything below it. The lower we go, the more specific we get, and the higher we go, the less specific we get. All right, so let's practice this a few times. All right, so this says name all sets of numbers to which each number belongs. All right, you don't have to write the whole word. Let's put our letters again. Real, Irrational, right? Rational. What is the next one? Integer, but we're not using integer. What are we using? Z. Z for integer. W for whole. And N for natural. Alright, so all you have to do is list which ones it falls under. Alright, so 30 is all of them. It's real, rational, it's an integer, a whole number, and a natural number. The only one it is not is irrational. So put real, rational, integer, whole, and natural. Right? This is just to get an idea of what numbers actually are, because when you start dealing with complicated math, they're going to tell you what types of numbers you can use. You need to know the types of numbers. Square root of 21. I don't even know what that would be. What would be the square root of 21? I'll let you figure it out. Negative 11. It's real, rational, integer, but not whole. So real, rational, integer. 5 4/7. Real, rational, but not an integer because it has a fraction. So we're just going to go with real, rational. Square root of 21 is not a square number. I don't think it's a decimal that ends either. So let's go ahead and label this one real but irrational. Right? That's as low as it goes, is irrational. 0, real, rational, integer, and whole, but not natural. Negative, square root of 9. It's actually going to be -3, which is an integer. So we're going to go real, rational, integer. Right? Because the square root of 9 is 3. 3 times 3. And then you just bring out the 3, right? So it looks crazy, but it actually is considered a rational number because it's a perfect square. 6 divided by 3 is 2, which is all of them. Real, rational, integer, whole, natural. Pi was one of the ones. We say pi is 3.14, but that's just a rounding. The truth is, pi is a never-ending, non-repeating decimal. There's a computer somewhere that's still trying to calculate the end of pi, and it's something like 2 billion digits past the decimal. So we can go ahead and call this real, but irrational, because you're never going to have a perfect calculation with pi, because 3.14 is a rounding of the decimal, so it's never going to be quite right. 5.3 repeating, we can call that real and rational because it repeats. Real and rational. 140, square root of 144 over -3. The square root of 144 is 12, because 12 times 12 is 144. 12 over -3 is -4. -4 is an integer. So real, rational, integer. -2 point. As soon as you saw the point, you knew it was a decimal. It is not natural. It is not whole. It is not an integer, which means only real and rational. As soon as you saw the decimal, you knew that it had to be real and rational. And as soon as you see a fraction, if it can't be simplified, then it's also going to stop at real and rational. But this fraction can be simplified. right? Anything over itself is 1, right? So the square root of 17 over the square root of 17 is 1. And that's real, rational, integer, whole, and natural. That's all of them. All right? So you should be able to watch this short video, and then you should be able to, after you've taken your guided notes and you're comfortable, start on the practice sheet, and when you're ready, you can do the mastery check. See, short. Told you it was going to be short.